there's no air behind it, okay? So we have to put a waste stack and a vents in order to, let air get into the system so that the water can, imagine like a straw. Put your finger over your straw. Pick it up. No, straw. Put your finger over it, pick it up. Yeah. See how it's full of liquid?
Let it go.
Now, let it go.
Let your finger, no.
And now it's empty. It's the same principle in which a vent sack works.
Should put it up here.
Alright? If it's just like a straw, the water can't get out because it's vacuum locked in. As soon as you let your finger go and you let air into the system, it'll drain. But it won't drain quickly. Now don't get me wrong, if she held her finger up there for 45 minutes or an hour, it might drip a few times and then there might be a little bit of air go through it. So it might drain slowly, but it won't drain quickly as you need it to drain.
Sweated fittings.
I just told him what it was, and it's copper, it's when you, silver solder copper lines.
Why do we silver solder them?
That's how you bond copper.
Well,
Uh-huh.
That's how you bond copper.
the reason why you silver solder them is because they originally used lead solder, and lead is poisonous to humans, so we don't do that anymore, so we use silver.
Okay, so soldering means cutting. Sorry.
No, it means taking two pipes together and heating them and adding silver solder, and it makes a solid joint.
Okay, so we're just connecting them.
Yep.
Thank you. Soldering is connecting them in this case, but we kind of like warm them up so that we can mesh them together.
Yeah.
So
It's like
soldering
you
is
get
welding.
You get the two pipes hot, alright?
All right.
Real hot, and then you take the wire, and then real hot. And then you take the wire and you just drag it along the gap, and it closes the gap.
Okay.
What is it?
So soldering
600
is like
degrees of
heating.
oil, soldering is 600 volt,
Yes, it is,
anything above 600 is considered welding.
Thank you.
so it's like,
Soldering.
Alright, so, stages of plumbing. Stage 1's underground. Prior to pouring the foundation, don't always have to be prior to pouring the foundation. A lot of times we pour the foundation and we dig underneath it. In residential especially. Commercial, typically not, because the foundations are so much bigger and it takes a lot harder to put in. Residential, a lot of times, they'll go put everything in and then they'll put the water line in later and the sewer line in later. Sometimes you'll put a sleeve in for them to come in, sometimes you don't. Alright, so residentially, let's get into this real quick. Residentially, things aren't as big and there's not, there's also this kind of like, I'm here, you're not. Whoever gets their work done first, it gets going. So if you don't hire the plumber until after the foundation's in, there ain't gonna be no stuff in. So, but on commercial work, it's a difference because they don't want you going and undermining the foundation because it could cause a failure because we have a lot stronger, bigger buildings. So prior to the foundation, we put the underground in. So what are we putting? We're putting it in the water service and we're putting it in the drain. That would be plumbing, okay? Sometimes we might even be looking at, like roofing. Like, see these two pipes here that run down? Go down that corner? Those are not sewer pipes, those are rainwater pipes. So they would have put those in before as well. So storm sewer or rainwater or whatever you wanna call it, river drainage, those could also be done underground before. Rough in is stage 2. So that means we have it in the building, the foundation's in, now, like, these two bathrooms that are right down here, they've gotta run all the pipes to every little spot where you have a toilet or a sink or anything like that. So they'll pre-plumb before the slab is poured. So underground is bringing it in to the building, and you'll just push it up, and then they pour the foundation, the perimeter foundation. Then under the stage 2 rough end is you're gonna put in everything under the slab out through the floor where it goes. If there's not a slab, the rough end would be, like drilling through the wood floor and everything else on a residential. Now, you're running them through the floor so that later on, you can put the toilet down, you can put your sink on the wall, you can put your showers in, whatever it might be. And this is the installation of the water in the sewer.
Are you talking about the stubs?
Huh?
The stubs that come up?
Yeah, just that rough end is just getting the stub through the floor so that you can make the connection later. The reason why they're calling it this stages is because you can't do all this at once. For example, why can't, when I'm doing my underground, I put all the lines in the floor? Well, because the building could shift 5-6 inches each direction. I mean, if you don't have the building layout done and the foundations to measure off of, you can't accurately put, because if there's a mid stack in this wall, I don't want it 6 inches away from this wall, and I don't want to move that wall. It needs to be exactly where that wall's at. So they run the rough end in before there's anything here, and they just move it in the middle of the building. Or just maybe they might just move it 3 foot inside of the outside wall, okay? And then they pour their foundation and they get their perimeter set exactly where it's at. Now you can measure and figure out exactly where this wall is so that you can put the plumbing stack in the wall. Otherwise, we'd have plumbing like that over there. We'd see it in the room. Now, of course, they intended that to happen, but for example, I have talked Habitat out of pouring slabs. Because the first 2 or 3 houses we built were slab houses, and they are using apprentice plumbers, and and the plans aren't very good. So you got to kind of make judgment calls, like what we did on the Habitat house. Well, what is that? Well, let's go ahead and put that on this side of the line. Let's put that on that side of the line. Well, if we make a decision different than what the plumbers do, we build all of our prefab, all of our stuff here at the house or at the shop, and then take it there, and we set everything up. Every time we were missing all the plumbing. The plumbers would set it on the opposite side of the line. When we get there, we set our wall, and the plumbing's over here. And you're like, that plumbing can't be in the middle of the room, so we'd have to move all our stuff, move our doors, move our windows, move all kinds of stuff in order to get the plumbing inside the wall. So I told them, no more to that. You get put on a wood floor, we'll build all of the walls, and you can drill through the wood floor and put the pipes exactly where they go. That way we don't have to worry about, because it was taking us an extra day to fix all the crap. Now, stage 3 on plumbing is finished plumbing. This is where we come in. So the rough end would get this up and stuck out the wall. It wouldn't even have these valves on it, okay? This is a hot water line, that's a cold water line, that's the sewer. So the rough end takes it from coming inside the building to running up in the wall and sticking out the wall so that they can put the tile and do all the stuff. Then the finish, you come in and you cut the ends of the pipe off, you put your valves on, you put your drains in, you set your sinks, you set your faucets, you do all it, and you finish the product. This is done in the 3 stages. Does that make sense? Because I can't hang this sink before they put the tile on the wall. So I have to let somebody else do some work with it. This is stage 1. I would even call this a little bit further than stage 1. They're calling this underground, but a lot of times the underground is just getting inside the building. This is actually doing some of the roughing, okay? This is roughing. So now they've got all the pipes in the walls and set in where they want. And water distribution. All right, so depending on your code and where you're at, a lot of this stuff changes, but typically you have one main water line supply into the building. That water line supply normally goes to the hot water heater. And at the hot water heater, you put a T in, and one side goes to the hot water heater, and one side is your cold supply for the house. Typically, that's the way they do it. All right. Why why don't we just start running cold water everywhere in the building, and then at the end, go into the hot water heater, and then it come through? No, I want it to do it. You still got hot water.
When you should be mixing. You talk about running them through the same line.
Alright. So I have water coming into the building. Alright? Let's just run this. The hot water heater's over here. Alright, I have a sink here, and a toilet here, and a shower here, and a kitchen sink over here. Why don't I run this hot water to all these like that? And then out of this, I run over here.
Cause it could get colder in the process by going around so much, maybe?
The main reason is I want to have one spot to turn off the water for the whole building. Okay? So if I run the hot water, if I run the incoming water directly to the hot water heater and then split off, and then these things run everywhere together. Now I can put one shut off right there, and I can shut the entire system off as it comes into the building.
That's for emergencies, right?
Yeah.
Or
Well,
maintenance.
I mean, it's for everything.
Maintenance.
If I have if I wanna replace a sink, I can just turn the hot water off in one spot. So, typically, we're gonna run the hot water to the hot water heater, or we're gonna run the incoming water to the hot water heater, and then we're gonna branch off from there. And then those lines will go together everywhere they go. So you got hot and cold. It's like salt and pepper travel together. I mean, hot and water, hot and cold travel together. So you want, anybody ever heard that? Salt and pepper travel together?
No, I never have.
I can't remember who it was. I think it was my sister's husband. You would ask for salt at the table, and he would hand you salt and pepper. And, well, I just did salt, pepper, travel together. So it was his rule in the house, no matter, they always went, if you asked for one, you got both, and then they always stayed together.
I've heard about sewing with butter. I thought that was a cool terminology.
All pipes that distribute to hot water heater sinks, control valves. all that. So, can't really see it very well, but right here is the incoming water. It runs in, it cooks off to everything, as it branches. Can't really see it so much. Here's some plumbing symbols. Cold water line is a long line, short line, long line, short line. Hot water is long line, double short. Hot line, double short. Soft water is a straight line with an SW in the middle of it. What's soft water?
Drinking water, shower water.
No. It's water that's been softened. It's went through a water softener. It's not straight out of the tap. Alright?
It's gross.
We're very lucky in Southern Illinois. Unless you're in Marion, I don't really know about Carbondale. Carbondale got good water?
No.
Garbage, absolute garbage.
Nothing's good about
Alright, what about Carterville? Who's got good water?
I've
right
heard
out of the
Lincoln
sink.
Agents.
Carterville or anywhere?
Anywhere. You got good water? Right out of the sink? Where you at? Alright, so here's the thing. Part of Marion is on Lake Egypt. part of Marion is on Wren Lake, right? The Wren Lake water, is run through some old lines that is not very good. It's kind of brown, kind of tastes bad. The Lake of Egypt water is actually, voted the best tasting water in the nation.
Who?
What?
Yeah, Chris McClure.
That's filtered water, that's not.
It's terrible.
That's
We're talking about like straight out the.
straight out of the pipe, straight out of your sink.
Out of your municipality.
Yeah. So, Lake of Egypt is voted the best tasting water in the nation last year. They sent off samples of a bunch of people. It's the best tasting water. So, is that my water? Did I just grab somebody's water? Too late now. Anyway, point being that,
Let's hope
if
we're
you're
not
on Lake of
running.
Egypt water and you have water softener, that's probably pretty dumb, because they have, it's already very well, it tastes good, it's not hard, it's not got a bunch of calcium in it, so it doesn't really make much sense to treat it. How do we treat water? How do you soften water? Salt, right, so I don't know exactly what the chemical, process is, but basically you run the water over salt, and it, adds some different, basically takes the acidity and some of the chlorine out, but it adds salt to it, so I don't know really if that's good for your health or not. This is a meter, this is a gate valve, a little, thing that looks like a hourglass that turns sideways. It's a gate valve, that means it's got a valve that you can turn off and on, alright? This is a 90, that's a 45, these are just fittings, guys, so sometimes, depending on, the complexity of the project and the plans, they will tell you what fittings to use in what location. And when we get into those drawings, those are called schematics, plumbing schematics, because they'll actually have the different fittings on them. There's an elbow turned up, so if we're looking down at it and you see a line with a thing, that means that you'll be looking right at the pipe as it come out of the floor, looking down on it. The elbow turned down, you'll see the line go in the middle. Elbow turned up, you won't see the line. This is a hose bib. You guys know what a hose bib is? It's what you put your hose on the outside of the house.
Okay.
Put the valve on, hose bib. Gas line, darker line is solid, a vent pipe is just a dash line. Through the roof is just a hole. Fire department, floor drain, not fire department, SD, floor drain, that means we got one on the floor. A V drain in 4 sections. This is a clean out. This is a clean out that's coming up, and this is a clean out that's at a 45-degree angle, that's a Y. Actually, this is called a Y. There's a coupling, there's a horizontal T, there's a turned up T, there's a turned down T. The difference between a turned up and turned down is you see the line inside the circle. If it's down, you see the line. If it's up, you see the circle. This is an isometric drawing of, in a schematic, isometric, alright?
Okay. 45-degree angle-ish, 32-ish angle,
Yeah, it is. I'll look it up.
something like that.
We're looking at it at an angle. Now, only plumbers look at it like this for the most part, okay? Because this really isn't what I would consider to be a layman. They're not gonna look at this and go, oh yeah, this is what it is. For example, is this a 2 or 3 story building? What is it? Can you tell?
No.
I think it's a two-story building. I think, this, and this are one level, this goes up here, and then this is the second level. Alright, this is a urinal and a lavatory and a toilet, urinal, lavatory, toilet. This over here is a service bank for, this is a urinal, yeah, so you have a urinal on this side and a toilet on this side, water closet, WC, that's what that means. WC, WC, WC. So this is a girl's bathroom on this side, this is a boy's bathroom on this side. This down here looks like the kitchen. This one here is a boy's bathroom on this side, girl's bathroom on that side.
How do you know which one's a urinal and which one's a toilet?
It says urinal right there, and this is water closet, WC's.
Oh, yeah, sorry.
Water closet, toilet, wow.
Alright, so we have what they consider to be, tankless hot water heaters. So I have one in the wrestling room,
On the menu.
it's on demand, but it only heats the water as you use it, right? That's why they call it on demand. So it instantly superheats the water, and by superheat, I mean runs it up to temperature, but it goes from 50 to 105 to 110 degrees like that, as fast as it goes through the machine. So we're not heating water all day long. Like most of us have a 40 to 50 gallon hot water heater at their house. And you're heating 50 gallons of hot water all day long, every day. If you go on vacation for a week and you're not turning on the hot water, you still have 50 gallons that you're keeping heated all week, okay? The tankless is supposed to be cheaper because you only heat what you need. And when you're not using any water, it's not heating anything. So they say that it's a lot more efficient. I'm gonna tell you that I'm not an overly big fan of converting a water heater to an electric tankless. The reason why is most people don't have enough power in their house to run an electric. Everything else is there. Why would I say that? Because it takes like 2 or 3 sets of breakers to run an electric tankless. So if your house is already maxed out on power like mine is, my house is maxed out on power. What I mean by that is I kept throwing my main breaker. It's a 200 amp service. I don't have a big house, but I have a lot of stuff in it. And I kept blowing the main breaker. So I went and tested my system. I put an amp meter right at the base of the
I'm having trouble
main
hearing you.
breaker, and I went in and I turned the air conditioner on, and I opened the refrigerator door, and I turned on the washer and the dryer, and I went through and I turned everything on in the entire house. And I was at 192 amps. Okay? I had a gas hot water heater. So that means I wasn't using my hot water heater with electric. If I switched that system over to an electric hot water heater, I would have pulled another 60 amps so that would have put me at 255 or 252, something like that. So I would have been over my 200 amps on my house if I had electric hot water. Now, that's saying everything's on at once. Typically, that's not the case. You don't go through and turn every light on in that house. You don't go through and open your refrigerator and run your washer and your dryer at the exact same time, and turn the bathroom fans on,
I do.
turn your stove, run your stove full blast. Double. We got a double oven, so it's on both sides. So there's lots of things that you typically don't use all at once, and that's the reason why you get by with having 200 amp service. But with the tankless hot water heater, it pulls a full 60 amps. Whenever it turns on, it pulls the full amount. All right. So I don't necessarily know that it's That's like my hot water heater at the wrestling room. It probably only works maybe a minute a day, 5 minutes a day tops. Cause just while you're washing your hands. Or if you're maybe somebody takes a shower there once. So here are the different types of pipe. Galvanized steel pipe. The least attractive is the galvanized steel pipe. Steel pipe rusts and corrodes. So, I'm not a big fan of it. Why would we use it? If it rusts and corrodes. You want rusty brown water in your house? No, we use it for water. No. A lot of times we use it in places where we need stability, like rigid stability. Like for example, on an outside hydrant, if we just ran copper or PEX up to the bottom of it, every time we pull on that hydrant, it moves a little bit. And by putting that galvanized steel underneath it, it's strong. I mean, it doesn't flex. So if we're gonna do something like this, it's probably because we're in an area where we need rigidity. I mean, we have something that's better than handle. Maybe, I don't know. Copper pipe is probably the best. It's by far the most expensive. Okay. PEX is, in my opinion, taking over everything. I don't see how we're going to, in the next 20 years, I think it'll probably be code that you have to use PEX. There are instances where copper is better. Copper is better. There's no doubt copper is better. But there are incidents where you need copper rigidity. Also, in areas that maybe have high water standards, stuff like that. I know that PEX will do just about everything, and I like it. It's quick, it's easy, it's flexible. The advantage, let's see if they go. So here, let's just go through it. So this is silver solder, no lead in it. Guys, they have lead solder. You can still buy lead solder everywhere you go. So you have to make sure you're using water. This is for potable solder for potable water. Potable means drinkable. It's not recommended to be put in concrete. All right, so we want to probably, if we are running in concrete, we want to wrap it in some type of insulation because of concrete and this doesn't work together. Contact with other metal because copper is soft metal and everything else is probably going to be harder. And if it moves and vibrates, what's going to happen? Copper is going to break down, not the other pipes. You're going to have water leak. And you either sweat or thread all of the fittings. Galvanized steel pipe has great strength and dimensional stability. It's coated to go against rusting, but it still rusts. Plastic pipe. Types of plastic pipe. PVC is what we use on sewers. CPVC is what we use for water, hot or cold. You can use PVC for cold water supply, but you can't use PVC for hot water supply. So you have to use CPVC for hot water. I am against it. All right. Since PEX came out, I'm against CPVC. It's brittle, it breaks. It's very easy to work with, but you have to use glues and other chemicals. So in my opinion, CPVC should probably go the way of the dinosaur.
Do you know why they use clay pipes?
Why?
Yeah, why?
It's cheap. They didn't have the ability to make plastic pipes. PEX is a cross-links, polyurethane. I like it. We'll go into a little bit more about that. It's ABS is for sewer. It's, you have PVC and you have ABC for, ABC is kind of a hollow core, so it's light. Here is set plumbing plans for residential. There's the house. It shows where everything's at, the toilet, the sink, and everything. And then this is what it looks like in schematic view, the isometric schematic view. Same drawing. Just shows you where all the fittings are and what's going on. Same way here. Here's the plumbing fixture schedule. It works just like the door and window schedule. It says EWC1 is the water cooler, EWH is the water heater, water hammer arrestor, and it tells you what they're made of, what type it is, what type of finish it is. Here is a blow up. This is the detail of the plumbing drawing. So there's what it looks like in schematic, and then we blew it up so we can see it up close.
In this scheduling charts, is that, is there more than one scheduling chart? Or is this a plumbing, or is that the whole chart?
I'm not gonna say that there wouldn't be more than one schedule on a plan, but, typically there's a schedule. You gotta go, there's no, not going. I guess I don't really. Oh, yes. Every job will have its, some won't have a plumbing fixture chart at all, you just have to go to spec book and find all of it out. Some will have a door, some will have a door, some will have a window. And there'll be. Drain, waste, sewer vent systems. Is there sewer pipe? You can use plastic or cast iron. Fuel oil systems, sometimes gas or oil. The piping is either black iron galvanized or yellow brass. Alright. Copper tubing is banned for gas systems. It corrodes and exposes with some gases. So black iron galvanized or yellow brass. Can't use copper on gas, propane or natural gas. Here are your codes. You got the Uniform Plumbing Code, the International Plumbing Code, and code provisions include kinds and sizes of pipes to be used, locations of traps and cleanouts. Guys, locations of traps, cleanouts, and vent pipes are probably where most mistakes are made. What I mean by that is there's a reason why you need to be a licensed plumber, and it's because there's a lot of calculations and a lot of stuff that needs to be set up in order for for the system to work correctly. So you need to have a trap within so many feet of something, or within so many inches of something. You need to have cleanouts because people flush tampons and condoms and all other kinds of things down the toilet, and water, paper towels, and people do that. So you have to be able to clean the system out. So you need to have access, especially in commercial. You guys ever seen those silver plates on the wall that has a screw in the middle of it? That is a cleanout. You unscrew that screw, pop it out. Behind it will be a cap. Take the cap out, and you can run a sewer line down fish tape or a roto-rooter down that, that's what that's for. And, I mean, most toilets commercially will have that above it, or it'll have it at the end where you can get to it. If they don't have that, probably there's a chase behind the wall that they can walk in, and that's behind the wall that they can just walk into. The 1950s, they were doing these chases. They called them wet walls, and they were literally this far apart, and all the plumbing in it was inside of that area. And imagine having to walk down a hallway this wide that has plumbing pipes everywhere. I don't know why they did it that way. Now, pretty much, they're opened up about like this, so the plumbing goes on both sides. You can walk in it. But you'll find in a lot of the old schools there'll be a little narrow door in between the bathrooms. And it's a narrow door too. It's like this wide. You open that door and it's just a chase down through there, and it's kind of dumb. But there's a reason why you have licensed plumbers, because you need to be able to run these calculations and understand how the system works. Because if you don't, like for example, I put in a bathroom in Goreville for a guy in his barn. Okay, there was no place to put the vent up, so I put the vent like 10 or 12 feet away. It would not work. I could not get that bathroom to work. I ended up having to come back in and put the vent in up through the middle of his barn where he could see it. He didn't want it there, but we tried for like 4 or 5 months. We could not get the system to work. I moved the vent closer to the toilet. Bam, it worked immediately. Because there was either water or there was something that was stopping it from pulling air. Fixture requirements. Guys, plumbers are very good at a few things. ADA. There's all kinds of rules for what type of lever to have on the, because if you don't have any hands, you can't have valves. Round valves, can you? You gotta have a lever handle. That's the reason why a lot of times we have the automatic ones now, because 88 says you should be able to just wave something in front of it and the water come on. You shouldn't have to have hands. What if you don't have any arms? You gonna turn the faucet on with your mouth? Seriously. So, the things that you don't think about will fill up this room of the different circumstances that you. What if you're a quadriplegic? You can't move your arms. How are you going to get into a building? Well, that's the reason why there's those push buttons. They've got push buttons at a certain height, and they got something on their wheelchair that they can just turn and hit the button, and it will open the door, and then they can go in. So they're not using their hands to push the button, because they can't.
ADA, American.
Disability Act.
Oh, ADA.
So plumbers are very good at this stuff, and they're constantly dealing with it. For example, the height of the grab bars in the bathroom, the height of the toilets, the height of the sinks. You have to be able to get a wheelchair under the sink, but you also have to be able to reach the faucet. So there's lots of things like that come into this plumbing code that you don't really even think about. Leak testing is conducted on the water and the waste lines. So depending on the building, sometimes they'll make you do what they call a standpipe. So you'll have to close off the system and like put a 10-foot pipe up in there and fill it full of water, and it's got to hold. It can't. The water, once you get it full, it's got to stay full for 24 hours or 48 hours. That's how you test sewer lines. On the opposite side, on water lines, a lot of times there's two ways you can do it. You put a pressure gauge on it, pump it up with air, pump it to like 60 or 70 pounds of air and leave, and come back the next day. And if it's still at the same, as close to the same as it was, you're good to go. You turn the water on. We used to do, on we did a lot of CPVC when I was younger, and we would test every system. We had a pressure gauge, we would put it on it, you pump it to 60 pounds of pressure, and you go home for the day. You come in the next morning, if it's still at 60, we were good. If it wasn't at 60, we had to go figure out where the leak was. Don't have to do that near as bad. Copper, PEX,
Sorry,
not
what were
overly
you using
concerned
then
with
when
it.
you had to check it?
Huh?
Before the copper, what was it when you had to check it all the time like that?
I would always check CPVC.
CPVC, that's why you hate it, you think it's gonna go out.
Well, the issue is, yeah, I hate it,
Alright.
it's gonna go out, but also, a lot of times you dry fit stuff together, and with CPVC, when you dry fit everything together, and if you miss one, you have a major leak. So that's the reason why we always want to check it. Copper's a little different. You can visually see if you've soldered the joints, you can visually inspect it. What time is it? 10:50, 9:50. Yeah, okay, so she didn't take too bad. Alright, do 13.1 and 13.2, you got an hour to